Right. So we were talking the last day about JavaScript functions. Functions are the unit of logic in JavaScript, and there are different ways of declaring functions, pre-ES6 and post-ES6, function declarations, function expressions. Then ES6 brought in arrow functions, and there's always been this notion of anonymous functions as well. And we looked at how we, with the exception of anonymous functions, we looked at the syntax for declaring all of those the last day. There's this notion of higher order functions, and we see them an awful lot in the throughout this module. So I want to cover them, and the syntax is a little bit unnerving initially when you work with it, but then you just get used to it. A higher order function is a function that takes another function as a parameter or an argument. We tend to call the function that's being passed in a callback, as in the function is called back by the main function, if you like. And so just by way of, so this is kind of syntactically like the parent function is just an ordinary function. It just happens to be that one of its arguments is actually a callback function, and somewhere within the body of this, it just invokes that callback function. I was saying then down here that we usually code the callback as an anonymous function, which we still haven't seen, but simply an anonymous function is a function that doesn't have a name. So just take out the name part and there you have it. So just by way of illustrating these anonymous functions, I just randomly picked the array data type, and it has a whole bunch of higher order functions associated with it, which are kind of nice to look at. But the main purpose of this is just to illustrate higher order functions and the notion of them, but to have something tangible. So there's this bunch of array related functions for each, filter, map, reduce, and we're just going to look at them one by one. The for each higher order function generically kind of looks like this. Okay, so I've got some array of some things. It doesn't really matter what they are. Here I'm calling the for each method on my array, and it only takes one argument. Some of them higher order functions take more than one, but here this function here is the argument to for each, and it's an anonymous function because it doesn't have any name. Now what for each does is it invokes this function once for each element in the source array, hence the name for each. And every time it calls this function, it passes in a reference to the current array element that's being processed, the index position of that element, and it actually also passes in the entire array. And the body of the anonymous function can do whatever it wants to. Okay, so that's simply how it works. So yeah, it calls the anonymous function for each element in the source array. We tend to use the anonymous function there. I'm using the function declaration syntax. We tend to use the arrow syntax more commonly nowadays. So, but you know, it's the same difference really. I'm stopping and starting now because I keep getting messages up saying somebody's trying to get into the meeting and I'm just admitting them. So that's why I'm kind of stumbling my way through this. Really, the for each is just an alternative to writing a for loop. We find ourselves writing standard for loops very rarely, really, in JavaScript, as it turns out. And so, you know, the most common use of a for loop is when you want to iterate over an array. Well, you would no longer use a for loop. You can if you want to, but it's not kind of idiomatic JavaScript, if you like. You would tend to use the for each instead. So let's look at an example. That's not what you want to look at. Okay, so here's a simple array of numbers, and here I'm just iterating over them. And all I'm doing is I'm just console.log what's being passed into me. So that's not terribly interesting, but there you go. Anyway, there's the only thing is that I'm using the arrow function style here. Down here, I've got another example. I'm declaring a variable, initializing it to 0, and it looks like what I'm doing here is I'm looking for all even numbers in my array. So every time this arrow function is called, I'm checking to see n. N is a reference to the array element. You know, up here I'm using n index and array, but it turns out that these two arguments are optional. You don't have to pass them into the anonymous function. You would only pass them in if you need them. Down here, I don't need them. Down here, I don't need them. So I've left them out. That's a nice thing about or a characteristic of JavaScript functions. You have this notion of optional arguments. So I've left them out down here. I'm just taking a reference to the array element. And it looks like what I'm doing is, you know, I'm just doing division by 0. If the result of division by 0 is equal to 0, more properly, I should have had the triple equals there, I'd say, really. Would be better coding. Then essentially return 1, otherwise return 0. And what am I doing with the 1 and 0? I'm just adding it to the current value of the evens variable that I've declared up here. So I'm just computing the number of evens in my array, and then I'm just outputting it. Yeah. Now there's actually a better way of doing that. For each is not the best option for doing that kind of computation, as we'll see in a second. Just before I move on, are there any questions about that? This is the first higher order function that we've seen. If you've used lambdas in Java, then this idea of passing lambdas into methods is familiar to you, but if you haven't, then it's kind of a new idea. Any questions about it, I wonder? No? Okay, let's move on. So that's the for each, and then I said in the previous slide, there are these other higher order functions as well, filter, map, reduce. Now, in order to demonstrate those, I've decided just to bring in something else that will become useful to us later on. So I'm kind of going off on a tangent now. There is this website called the Random User Generator website. And if you send it a HTTP request, if you send it a HTTP request, something like this to this website, what it will return back to you is a randomly generated array of user profiles. In fact, if I just click on this link right now, okay, it's giving me back, essentially it's giving me back data. It's not sending me back any HTML, it's sending back data. This type of website we refer to as a web API. A web API is a web server that returns data to you of some nature. In this case, the data is just randomly generated user profiles. Web APIs are really a very important part of this module, but the second half of it. And the data that is returning back to me is in JSON form, is in the form of JSON, and JSON is just it's essentially JavaScript objects. So in this case, it's returning 10 user profiles. The 10 is actually coming from here, right? If I just reduce it to 1, then we get a nice idea as to what exactly is inside a profile. Okay, so it's just one user is returning back to me, and this is the full details on that user. Okay, but it's returning in an object where the key of there's only one entry, one property in the object. Its key is results, and the value of that key looks like it's an array, and it's an array of objects. In this case, there's only one object in the array. Okay, so that's this random user web API that we can use. Now, the way I'm actually using it is like this. So in the little demos that we're going to look at now in a few minutes, we actually have two servers playing a role. We have the live server that's running from VS Code. And what that is doing is it's sending HTML and JavaScript down to my browser. And the JavaScript then is actually sending a HTTP request to this random user web API, and it's returning back user profiles, randomly generated user profiles in the form of JSON, which is essentially just a JavaScript object. And I'm processing that data then inside here. And really the processing involves just outputting something to the browser's console. Okay, so that's kind of the context for the remaining array higher order functions that I'm going to be looking at. So it's pretty involved really, but this actual architecture will resemble what we'll be doing for the rest of this module, a very, very simplified version of it. All I'm showing you here is this thing called Postman. I don't know if you've heard of it. Postman is it comes in the form of an app or a Chrome plugin, and it's a very useful tool for playing with web APIs. Again, this is a web API. We would classify it as a web API. This is a very simple web API, though. If you had a more complex web API and you wanted to interact with it, you wouldn't use an ordinary browser as I did there a moment ago. You would use something like Postman to play with it. We don't need to know about Postman now, but it will come back later on. Right, back to higher order functions. The first example I want to look at is what I'm calling the base example. And in this base example, I'm demonstrating two things. I'm demonstrating the for each higher order function yet again, and I'm also demonstrating something called fetch. Fetch is a function that's built into your web browser, and it allows the web browser to send HTTP requests to web servers. And of course, that's what I want. That's what I want down here. I want my JavaScript code to be able to send a HTTP request to the random user web API. And so this built-in function called fetch allows me to do that. So let's look at the sample. And as before, I need to change my index to now refer to that. And I need to start my server. Okay, so it's outputting essentially just the names of the user profiles that my code requested. Okay, let's look at the code. So here's the fetch function, and you just give it a URL, and it sends out the HTTP request. Now, there's some fancy stuff going on here, but just for now, right, take it from me that that this is just boilerplate, and when eventually, well, I suppose, okay, so fetch sends out the HTTP request, and when the response comes back from the web API, and of course, it's going to be an asynchronous response. It's not going to be immediate because it's across the network. Eventually, the response comes back, and when it does come back, the then function is invoked, and I'm passing to the then function an anonymous callback. What this does is it gathers together all of the response that came back from the web API and packs it into one response. It's possible that the response that comes back from the web API is actually fragmented into different chunks, and so it needs to reassemble that. And this one-liner will actually do that for me. Okay, you can take it as boilerplate, I suppose. So this function executes and it reassembles the fragments that have come back from the web API. And when that has been completed, of course, this is an anonymous kind of action as well, in that the fragments will come back over time. So eventually, when all of the fragments are back, when that occurs, this instance of the then method is called, and what's passed to that instance is yet another callback. So this callback is executed with the full body of the response from this original request. So response body, when I reference response body inside here, that is going to be the full body of the response that came back from the web API. And of course, we know what that looks like. It looks like something like that. What am I doing? I am accessing the results key within this object. This key here. So that expression is going to give me back an array of user profiles. So profiles is going to be an array of user profiles, and then I'm just iterating over them. And I'm just pulling out the person's name, their title and name, first name, second name, and console logging that. That's pretty tricky now, admittedly, for lecture number 3. I'll just go back over again. Okay, this sends out the HTTP request, but that is an anonymous action or event. Eventually, the response is going to come back in fragments. The then method, it calls this callback, and what this callback does is it reassembles all of those fragments into one unit. And when all of that has been done, the flow of control now comes down to here. This then method is called, and the then method invokes this callback. And what's passed into this callback is the full body of the response that was assembled up here. And then I just do whatever I want to inside here. Right, the reason there's a catch block here, the catch is really associated with the fetch, because, you know, maybe the server is down, maybe the web API is down, is not responding, or maybe the URL is incorrect. So there could be, the fetch could throw an exception. So that's why I've got the catch down here. And if only to confuse you even more, supposing I do a console.log of at end. Now, you would expect when this executes, this console.log stuff is going to execute first, and then this will execute. In other words, it's a sequential, you read this as a sequential flow of control, right? But look what actually happens. This actually comes out first, and then the for each, the iteration over the array of user profiles comes out. Is anybody brave enough to suggest why that might be the case? It's because of this whole idea that really this code up here is asynchronous, meaning that it executes sometime in the future, simply because we are making network calls. This is making a network call. We don't know when that actually response from that network call comes back to us. So there is something very sophisticated going on here, even though we program it as if it is a sequential kind of action. It's not really, or a synchronous piece of code. It's not actually a synchronous piece of code at all. It's asynchronous. I don't want to get into that whole area right now, but I suppose I'm just highlighting the fact that there is something kind of unusual going on here. And we've proven that by the fact that this console.log actually executes first, and then this console.log executes within the loop. But I would, from your point of view, I would tend to, for now, just treat this as boilerplate. If I want to make a HTTP call from my JavaScript that's running within the browser, use the fetch function, give it the URL, and then essentially just cut and paste this exactly as I have it there. And from then, within this callback here, then you need to check, well, what is the structure of the response that comes back from the web API? I've shown you the structure of the response from the random user. But if you were using a different web API, you would have to work out, well, you would have to discover, perhaps using Postman, what is the structure of the response that comes back. And that dictates then how you navigate the response body to find the actual data that you're looking for. That's the for each. And really the purpose of this base example is to explain exactly what's kind of going on here, right? And the fact that there is this whole asynchronous nature of the communication that's going on between the browser and the random user web API, and the fact that we can implement that though using the fetch function with these chained .then method calls. That is method chaining, isn't it? You've heard of method chaining. That's really what we're doing here. We're chaining on an invocation of the then method followed by another invocation of the then method. Okay. To illustrate the filter, first of all, the filter high order function, what it does is it takes your source array and it picks out certain elements within it based on the callback that has been passed to the filter. Essentially what the filter does is it invokes the callback, and the callback has to return a Boolean true or false. If it returns a true, then the particular element array element that's being processed, that element is added to an output array. If it's false, then it's not. Okay, so we're filtering the source array for certain array entries. The source array is not changed. Okay, so we would say that the filter is a pure function. It doesn't make any alterations to the source array. It creates a completely new, its output array is a completely new array that essentially contains a subset of references to elements in the source array. To illustrate, again, I'm using the random user web API. Just going to pause maybe for a second if people have any questions. I'm not sure. I was kind of rattled now by all this setting up the meeting, so I'm not sure if I've explained that base code sufficiently to you, or if you are in a position maybe to ask me any question about it to clarify any aspect of it. No, okay.
Is there a particular reason why why you get back the data kind of from the back as opposed to from the front?
The data is coming from a remote server.
Just the console.log, and it prints out that your last one first, like not kind of in the flow. Does that always going to happen the same way?
You're saying about this here?
Yeah.
That happens because the code that precedes it is not synchronous code, it's asynchronous code. So I guess I'll try and explain it like this, because I don't want to go into the technique. The technique that's being used is something called promises. So the fetch sends out the HTTP request, and it won't execute this until the response comes back, but it doesn't actually block the operating system of the browser thread waiting for the response to come back. It actually skips over it and continues on executing the code. So it doesn't block the thread. A browser is a single threaded execution environment, as you probably know. But the fetch function has something special about it. It uses something called promises, which you can read up if you want to. But my way of explaining promises to you now is that what fetch will do is it will, in the background, wait until the response comes back from the web API. And when it does come back, it will execute this. But it doesn't block the entire thread waiting for the response to come back. It just skips over all of this stuff and continues on executing anyway. So there might be a lot going on here. Eventually, the response comes back from the web API, and fetch is clever enough to remember, I've now got to execute this stuff because the response came back. So this could execute at any time. If I had a million console.logs here, then somewhere in the middle of that million being typed out or being printed out, eventually this stuff is going to be printed out somewhere in the middle of them. And that the when is really determined by how quickly the random user web API comes back with the response. Not sure if that.
Yeah, that makes a lot of sense. It's just kind of streamlined to try and get as much code and process as possible, as quickly as possible.
Yeah, the key thing is don't block the single thread of the browser's runtime environment. That would be a disaster from a user experience. If you think if we now have an app running in our browser, if we're doing online shopping, for example, which is really a web app running inside your browser, and the user clicks on something, and the clicking of something triggers your web app running in the browser to make a HTTP request, you don't ideally want to freeze up the entire user experience waiting for the response comes back. That's kind of the background to it. So it's all based on promises, this notion of promises, which is a technique not specific to JavaScript, and we will cover promises later on down the line. So filter has the same starting code. Okay, it's doing the same stuff, so I'm not going to go over that again. And the objective here I'm saying is find all just female profiles. Okay. Now, if you didn't know about filter, you'd write a for loop, something like this, okay, which you can look at later on yourself, but we don't do that. We use the filter instead. The filter is ideal for this objective of just picking out certain entries in our array. And so here's my filter, and filter is also a higher order function. And in the body of my function, I'm using in my anonymous function, I'm using the arrow function syntax. So it's passed in, for each invocation of this anonymous function, it's passed in a reference to the current user profile that's being processed. I'm passing in the index as well, only because I'm just console.logging it here. This is the important part though. Remember, the anonymous function that you pass to filter must return a Boolean. And if the Boolean value is true, then the particular array element that's being processed is going to be added to the output array. This is my output array. Okay, and you can see what I'm doing here. I'm just checking to see if the profile's gender is female. That expression is going to be true or false. The only reason I'm console.log here is just so you see something visual in the developer tools, and then I output the full array of females. So So this is the full array of profiles that I got back, and you can see there's a mixture of male and females. And then this is the actual array of females, just to confirm that it picked out the right ones. Yeah, you can look at that later on yourselves. Just another example of it here. I want to pick out all males under 40. So, you know, same idea. I have a filter, and here's the expression that evaluates to true or false. It's just a logical ending. Now, my anonymous function this time just has one line of code, and that one line is the return value of that anonymous function. So I'm using the shorthand form of the arrow function. The long-handed form would be use your parentheses, put in your curly braces to delineate the anonymous function body. Have an explicit return. Okay, all of that does the exact same, unless I've had a typo now. Did I do a typo? I didn't, no, okay. Yeah, but, and really as beginners, you know, you probably use the long-handed form, and then you realize I can actually use a shorthand form for that. Okay, so that's filter. The map higher order function, as the name kind of suggests, it maps over the source array to produce an output array, and for each element in the source, there is a corresponding element in the output array. So there's a one-to-one correspondence there. Again, the source array is not modified, so map is also a pure function. So just to look at an example, well, the callback that you pass to map, what it returns is what is put into the output array. And it's usually some sort of scaled down, trimmed down version of the source array element. Although it doesn't have to be, but. So let's look at map. Again, start of the code is the exact same. My objective is I want to create an array of just the profile email addresses. Yeah. Again, the old way of doing it would be a for loop. So in this array, there's going to be an element in this array, this output array. There's going to be an element in the output array for each element in the input array or source array. Unlike filter, where filter kind of, it was a subset of the source array that you were outputting. And here we go, profile.map, profiles.map. Here's my anonymous function again in the arrow syntax, and it's returning, I'm constructing an object here, and I'm returning that object. So this profile emails array is going to be an array of objects of this structure. And when I console.log it, I can confirm that. Obviously, you need to go back over each of these yourselves. So what am I outputting? Sorry. I'm outputting the full array, and then I'm just outputting the emails array. Yeah. Why am I getting 3 arrays there? Oh, sorry. Okay, this is the full array, I guess, is it? Yeah, that's the array that I got back from the web API. This is the array with emails and names. Oh, I'm doing some more stuff down here. All right, I just want to create an array just containing the profile, the user's ages, as you can see. So that would be the very last array. Okay, so that's map. The last one then is the reduce higher order function. It's a little bit trickier now than the other three, really. The general idea of the reduce higher order function is to take your source array and to produce a single accumulation value from that source array. So you want to go through each element in the source array and do some sort of accumulation, right? So whatever the nature of the accumulation is. And again, the source array is unchanged. And the callback that we pass to the reduce, that's responsible for building up your accumulated value. So I'm showing you the general form here first. So again, I'm passing it a callback as with all of them, but I'm passing it a second argument as well. Reduce is different from the other higher order functions that we looked at. Now, all of the higher order functions that we looked at in relation to array anyway, they just take one argument, the callback. That's just coincidental. Other higher order functions take many arguments. Reduce actually takes more than one argument. It takes a callback, and it takes another argument which needs to specify what is the initial value of the accumulation that you're doing, or the accumulator that you're computing. Okay, so that might be a primitive, or it could be an object or some type of or an array. Usually, if it's an object, it would be an empty object. If it's an array, it would be an empty array. It's the initial value for your accumulator. And the way the reduce works then is, as before, it calls the callback once for each element in the source array, and it passes in to that anonymous function the current value of the accumulator, the element of the array that's being processed, and the index position of that element and the entire array itself. Again, these two are optional. What the callback does is it takes the current value of the accumulator and it updates it based on the current element that it's processing. That updated accumulator is then the input to the next invocation of the callback. Okay, so each time the callback is invoked, the first argument is getting the most recently updated computed value for your accumulator. The first time this callback is invoked, which would be for the first element in the source array, the first time it's invoked, the accumulator gets its initial value from this. That's how it works. Let's see a tangible example. So my objective is, okay, calculate the average age of all of the profiles. So the accumulator, I'm obviously going to use reduce. The accumulator is going to be a kind of a summation of all of the ages as I go through my profiles. So I'm just going to start with 0, take the first user, take their age, add that to 0, then take the next user, get their age, add it to my accumulated value, and so on. So here I am in reduce, and here's my callback. Total is my accumulator. The initial value for total is 0, which makes sense. And in my callback, I'm simply taking the person's age and I'm adding it to total, which has been passed into me, and I'm returning this new computed value. So if we say the first user, their age is 20, the second user is 21, third user is 22, and so on, just for simplicity. That means that the first time this callback is invoked, total will be 0 because of this. And it's going to do the computation, and this computation is going to result in 21, because the first user is the age 21, I think. So I'm returning 21. That 21 now becomes the total value for the second invocation of this callback. I'm taking that second user's age, 22, adding it to 21. I get 43. I'm returning 43. 43 is now the total value for the third invocation of my callback, and so on. And then I'm just doing a computation. I'm dividing my accumulated value. Eventually, when reduce has gone through all of the entries, this is now going to be equal to the last accumulated value, if you like. And I'm just dividing it by the number of profiles to get the average age. As usual, I would have expected, I was hoping to be further down the line, but that's kind of the simplest illustration of it. What I'm doing down here is a little bit more involved. My objective here, I'm saying, is I want to find, oh no, sorry, this is straightforward enough, actually, no, well, relatively. I want to find the youngest person in my array of profiles, okay? And it wouldn't be obvious, I suppose, but the reduce actually does that for me as well, or I can use reduce to do that for me. And so in this case, I've decided that the initial value for my accumulator now doesn't really tally with my objective here, but this is where it becomes a little bit tricky as to deciding when to use reduce and when not. But reduce does do the job, but it wouldn't be the obvious choice. So I'm choosing the initial value for my accumulator. My objective now, as I said, is to find the youngest age. And I'm setting the initial value to be 100 because there's definitely, you know, the youngest is going to be younger than 100. I'm setting it to be 100. And then in my callback, so min here kind of makes sense, right? Min here is my accumulator, and it will be the youngest age that I've come across so far as I'm working my way through the array of users. Okay, because what am I doing in the body of the callback? I'm checking to see, is the current user that's being processed, is their age less than the min? If it is, then return that person's age. So that now becomes a new min, otherwise return the min that you were passed in. So as I'm working my way through that, I am either returning the minimum age that has been found so far, or I'm returning the age of the user that I'm currently processing because their age is younger than the youngest that I've found so far. So the trick really was to realize, well, I need to set the initial value to 100. If I set the initial value to 0, what's going to happen? Can you predict? Tricky one. If I set it to 0, well, based on the way that I wrote this here, right, nobody's age is going to be younger than 0. So this is the overall result is going to be 0. Right, that's what's going to happen there. So I've got to set it to something so that at least one person is going to have an age younger than the initial value. Right. This isn't a very involved example, and I'm going to let you look at it yourself, study it yourself, and see if you can work your head around it. Now, you are now in a position to work on this lab here, because this involves using a different web API. Forgot the name of the web API now, but it's detailed in the lab anyway. And you will be using those different array higher order functions. I'll give you the solutions, but do try and come up with the solutions before you actually look at the solution that I provide. Okay. Now, some of you said that you have to go to another class. I was hoping to talk through the overview, but looks like I'm not going to do that, get a chance to do that now. So, right, I'm going to pause it at that for now, unless people have any last minute questions that they have from me. Apologies now about the whole starting up of this meeting, but c'est la vie. No, okay. Let's call it there, and I'll talk to you again on Thursday at 4:15. As I said at the outset, I am taking all of the labs on this module for the first 5 weeks. Some of you did not have anybody allocated to your labs last week, and if you look at the timetable right now, there won't be anybody allocated to your labs, in particular the BSc applied people. But I'm just telling you that I am actually taking those labs this week. So I'll set up Zoom meetings, and really I'll initiate the meeting and I'll just kind of hang around. I won't be waffling on to you. You'll just be working your way through the particular lab, and if you've got any questions, and we can chat about it on Zoom. That's the way it's kind of going to work. But I will take all of the labs for this module for this week and for the next 4 or 5 weeks. All right, we'll leave it at that. I'll talk to you whenever. Thanks.